possible outcomes, right, in my sample space. There's 12 possible outcomes. One in head, one in tails. Two in heads, two in tails. I want to know what's the probability of getting a 5 and a heads. Well, if I look at all the possible things that could happen, that can happen one time out of 12. So my probability of getting a 5 and a heads is 1 out of every 12 times. All right? The point of today's lesson is I don't have to draw the sample space. I don't have to write out all the possible things that could happen because I can do it like this. I can multiply two probabilities. What's the probability when I roll a dice that I get a 5?
One out of 6.
Good, 1 out of 6. And then I'm going to do times. What's the probability when I flip a coin that I get heads?
Same 1 out of 6.
Nope, because how many things can you get when you flip a coin?
It's 1 out of 2.
Yeah, there's only 2 things you can get when you flip a coin, so it's 1 out of 2. And look what happens. 1 times 1 on top, 6 times 2 on the bottom. That's how we can get the 1/12.
Can you please read that again? This part and that part.
Yeah. So, first of all, did you follow the 1/12 when I got it by listing all the possible things that could happen and just looking at it?
Yeah, everything.
Okay, so that's one possible way to get a 5 and a head out of 12 possible things that could happen. But the other thing I could do is consider these two probabilities separately. If I want to know if I roll a dice, what's the probability of getting a 5? Well, there's 6 things that can happen when I roll a die, and a 5 is 1 out of those 6 things. All right? Now, what's the probability that I get heads when I flip a coin? Well, there's 2 possible things that I can get when I flip a coin, and heads is 1 of those 2 things. Well, if I multiply these 2 fractions, I'm going to get the correct answer. 1 times 1 on top gives me 1, and on the bottom, 6 times 2 gives me 12. All right? So there's a formula which we just really applied here. If you want to know the probability of 2 things happening, as long as those 2 things are independent of each other, as long as one can't affect the other, the probability of getting a 5 and a heads is just the probability of getting a 5 times the probability of getting a heads. Is that a little bit better, Olivier?
Yeah, thank you.
Okay, sure. All right, so now I'm going to show you some examples. We're going to do 8 examples together, and your classwork and homework are going to be just like them. Your classwork, you'll see there's 2 documents. The examples, you don't have to click on this now. I'm gonna be showing you how to do the examples, and then you can look at my answers. If you get stuck on the classwork, you can look at the examples for help. All right, so you don't have to click on that right now. We're going to run through this together. All right, there's going to be 6 probability problems and 2 problems where I ask you to list a sample space. All right, so reading number 1 together, it says a jewelry store sells gold and platinum rings. Each ring is fitted with a ruby, sapphire, emerald, or diamond. And we want to represent the sample space, which means the whole number of ways that I could pick a ring. All right? And it's going to look like this. I could pick, there's 2 types of metal for the ring and 4 types of stones for the stone. So I could hold on. What am I doing? I could buy What the heck? Hold on a second. Okay. All right. I could buy. It's crazy. All right. All right. Hello, Dio. All right. So I could buy a ring that's gold, and I could get a sapphire. I could buy a ring that's gold, and then I could pick an emerald for the stone. I could buy a ring that's gold. Oh, I missed ruby. And has a ruby. And I could pick a ring that's gold and has a diamond. Or I could pick a ring that's platinum and has a sapphire. I could pick a platinum ring with an emerald. I could pick a platinum ring with a ruby, or I could pick a platinum ring with a diamond. Did people understand what I just did, or did I not do a good enough job of explaining that? How are we feeling about that one?
So you're not sharing your screen.
Thank you. Oh my gosh, thank you very much. All right, so here we go. Now we can see this, right? All right, so there's two types of rings, gold and platinum. So you can see I've got one row that starts with gold and one row that starts with platinum. And then I've got 4 different settings, ruby, sapphire, emerald, or diamond. And why don't I put them in the correct order? Ruby, sapphire, just to make it a little more obvious. It doesn't have to be in any particular order, but if I'm giving you these for examples, I want you to make sure you understand that. All right, so I pick one of these for the type of ring, and I pick one of these 4 types of stones. So I could pick gold and ruby, gold and sapphire, gold and emerald, gold and diamond. That's these first 4 choices. Or I could pick platinum and ruby. So I put PR. Platinum and sapphire, PS. Platinum and emerald, PE. Or platinum and diamond. Let me show you another one and see if we understand or don't understand. A spinner, you can land on either red, blue, or green. So there's 3 things I can get on the spinner. Red, blue, or green. And I can flip a coin. A coin basically has heads or tails, right? So what could happen? What's my total sample space? On the spinner, I could get red and then a head, or I could get red and then a tail on the coin. I could get blue on the spinner and heads on the coin, or I could get blue on the spinner and tails on the coin. Sorry, blue, tail. Or I could get green on the spinner and heads on the coin, or I could get green on the spinner and tails on the coin. That's my sample space for this problem. Are you following that okay or not following it too well? Be honest.
I think one more example will help.
All right. How about okay, let's okay, let's say I told you you're ordering a pizza. You can get white or wheat crust. And then for your toppings, you can get pepperoni, sausage, or onions. And now I want the sample space. All right, so this has two choices, white or wheat. And for toppings, we've got three choices. So I'm going to have 6 things, 2 times 3 things in my sample space. I could get, let's call white will be W and wheat will be WH. I could get white crust and pepperoni. I could get a white crust with sausage. Let's assume we're only picking one topping. I could get white crust and onions. Or I could get wheat crust with pepperoni, wheat crust with sausage, or wheat crust with onions. Are we following that okay, or still no?
Yeah.
All right, well, feel free. This honestly isn't the most important part of what we're doing today. So we'll see how you're doing. Let's see how you're doing it. But if you're good on the probability and having a little trouble with the sample space, we're actually in okay shape. All right, so here's the type of problems we're going to do. A cooler contains 13 bottles of sports drink, 5 lemon lime, 3 orange, and 5 fruit punch. All right, they did the addition for us. 5 plus 3 plus 5 is 13. All right, we randomly grab a bottle. Then we return the bottle to the cooler. We mix up the bottles and randomly pick another bottle. I want to know what's the probability I get lemon lime both times. All right, well, if I read this carefully, there's 5 lemon lime drinks. So 5 out of 13. All right, and I'll just use a little X for times. All right, we're not going to try to make fractions look like fractions here. And then I want to get lemon lime the second time also. 5 divided by 13 equals, and we'll come back and give an answer in a minute. Let me compare this with number 4 just to help you understand this. Number 4 is almost the same kind of problem, except this time we have 12 bottles of sports drink. There's 4 lemon lime, 3 orange, and 5 fruit punch. The same situation. I'm going to reach in and randomly grab a bottle. Then I'm going to put it back, mix up the bottles, and pick another one. I want to know what's the probability I get lemon lime the first time and fruit punch the second time. How many lemon lime do we have? How many lemon lime?
4.
4. So the first time I've got a 4 out of 12 chance of picking lemon lime. And how many fruit punch flavor do we have?
5.
5. So the second time I've got a 5 out of 12 chance of getting fruit punch. And I'm going to multiply those two probabilities. Right. In the homework, I gave you 2 different links also for online calculators to help you multiply your fractions and get a reduced answer. The first link, I'll show that to you now, calculator soup. All right, I want to do 5/13 times 5/13. If you're using this one, click this little thing to multiply. All right, and once you do it once, it'll stay on multiply, even if you hit clear. I want to do 5/13 times 5/13, and you click calculate. And what's nice about this one is it'll explain why the answer is what it is, if you are curious about that. The bad thing about this one is sometimes it's slow. So it's working, it's working, it's working. And there's the answer right there, 25 over 169. So I'm going to come back here and type in 25 divided by 169. That's my final answer. If you click on the second link, I personally like the Desmos one a little better, but if you like the other one better, that's why I gave you options. So if you click on the second one, this time I want to do 4/12 times 5/12. The second link will bring you to Desmos. Do 4/12, and it'll automatically make a fraction. Right arrow, asterisk, or you can click on the times button. And the next one was 5/12, 5/12. And you can see over here it already gave me a decimal answer. If I click right here, it turns it into a fraction, 5 out of 36. That's the reduced answer. So I'm going to come over here and give the reduced answer 5 out of 36. How am I doing on explaining those two?
Good.
Okay. Let's mix it up a little bit. All right, number 5. We've got 7 nickels and 6 dimes in our pocket. So first of all, I got 7 plus 6. That's 13 coins. All right. Now I want to know what's the probability. I randomly pick a coin out of my pocket.
Right, Mister.
Yeah.
Can you do it again, please? Please.
Which one? Number 4?
Yeah.
Okay. All right. So I've got 12 drinks, right? I'm going to grab a bottle. Then I'm going to put it back and grab another bottle. All right. The first time I want to get lemon lime, and the second time I want to get fruit punch. So there's 12 bottles, right? It tells me right here there's 12 bottles. I want to get lemon lime the first time. Well, there's 4 lemon lime. So 4 out of 12 is my probability of getting lemon lime the first time. Now I want to get fruit punch. Well, up here it says there's 5 fruit punch flavor out of 12 bottles. So I've got a 5 out of 12 chance of getting fruit punch the second time. And then when I multiply these two fractions and I reduce, this is my final answer. Is that a little better, Magina, or no?
Yes, Mister. Thank you.
Sure. All right. So number 5, we've got 13 coins, right? 7 nickels and 6 dimes. I'm randomly picking a coin, putting it back, returning it to my pocket. Then I pick another coin. I want to know what's the probability I get a nickel the first time and a dime the second time. So a nickel, there are 7 nickels out of 13 coins. So I've got a 7 out of 13 chance of getting a nickel my first time. I'm going to multiply. What's my probability of getting a dime the second time? How many dimes do I have, Olivier?
6.
Yeah.
Yeah, I've got 6. So I've got a 6 out of 13 chance of getting a dime the second time. So I want to multiply 7 out of 13 times 6 out of 13. Hit the clear all button over here. 7/13 times 6/13. This one, you have to hit the fraction button to turn it into a fraction. 42 over 169. 42 divided by 169. Maybe I should have started with number 6 because number 6 is a little more straightforward. I flip a coin twice. I want to know what's the probability the first flip lands heads up and the second flip I get tails. Well, I've got a 1 out of 2 chance of getting heads the first time and 1 out of 2 chance of getting tails the second time. And we can use a calculator, but this one's kind of easy. 1 times 1 on top and 2 times 2 on the bottom. All right, take a look at these two and let me know if you understand them or you don't understand them.
I'm a little confused on that, Mr.
On both of them, 5 and 6? Are you confused on 5 and 6, Magina?
Only 6, Mr.
Only 6? Okay. So I want to get, I'm flipping a coin, right? And I want to get heads the first time. And then I want to get tails the second time. So when you flip a coin, what's the probability of getting heads? It's 1 out of 2, right?
Yeah.
And now I'm going to flip again. Now I want tails. Well, what's the probability of getting tails? It's still 1 out of 2. So the probability of getting heads and then a tails is going to be 1 out of 4.
Okay, thank you.
Sure. All right. Anybody else have any questions they want to ask on that? 5 or 6? All right, let's wrap this up then. I didn't really mean to keep you guys this long today, but I'm sure it was worth it. All right. A bag contains 7 red marbles and 3 blue marbles. So I'm thinking to myself, 7 plus 3, that's 10 marbles. All right. I'm going to randomly pick a marble. I'm going to put it back in the bag and then pick another marble. I want to know what's the probability of getting red and then blue. So red, I've got a 7 out of 10 chance. And then I want blue the second time. That's a 3 out of 10 chance. And then you just give an answer. Use the calculator if you need to. This one's going to be 21 divided by 100. All right, 8. I'm going to flip a coin and then I'm going to roll a dice. I want to get a tails on the coin and an odd number on the dice. What's the probability of getting a tails when I flip a coin? Anastasia, what's the probability of getting a tails when I flip a coin?
1 over 2.
All right, 1 out of 2, yeah. And then I want to get an odd number when I roll the dice. Well, there's 3 odd numbers. There's 1, 3, and 5. The other 3 numbers are even numbers. So I've got a 3 out of 6 chance which is the same as 1/2. And then, do it in your head or use one of the calculators, but this one's going to be 1/4. All right, 1/2 times 3/6 will give you 1/4. And if you use the other one, it'll explain to you why it's 1/4, if you're curious. All right, that's the work for today. If you feel like you understand it, you're welcome to log off and just work on the classwork and the homework. I want to show you, though, that if you click on the classwork, if you want to look at the examples, you'll see all the answers there. So if you need to look at this for ideas or how your work is supposed to look, you can look at the examples right there. But the one that I'm going to look at to grade you on is this one, probability classwork number 3. Okay? Any questions?
No.
All right. Then you're welcome to check out and do this at your own speed, or you can stay on the line and I'll be happy to help you through it.
Bye, Mr. Have a nice day.
You too, thank you. And Kayla, stick around for a minute. I'm going to take a look at your screen for you. November 4th.